Hello viewers and welcome to So What's the Cloud Anyways. From this course map you can see that you are at beginning of your journey through the Google Cloud Computing Foundation course. On completing this module you will be able to answer the question so what's the cloud anyways and discuss why the cloud is a technological and business game changer. So let us look at the objective for this module in more details. The objective of this module is for you to be able to discuss what the cloud is and why it is technological and business game changer. The specific learning objective to achieve this include you being able to discuss cloud computing, compare and contrast physical, virtual and cloud architect, define IaaS infrastructure as a service, PaaS platform as a service and SaaS software as a service infrastructure and identify some of the advantages of leveraging the cloud. So these are the agendas. This module starts by discussing the characteristics of cloud computing before looking at how traditional architectures compare to the cloud. We will then look at the key difference between infrastructure as a service, platform as a service and software as a service together with the Google Cloud services that fall within these categories. The final topic will focus on Google's specific offering in the cloud. So we will end the module with a short quiz and a particular module recap. So let us go ahead and look at the characteristics of cloud computing. So cloud computing has five fundamental characteristics. First, computing resources are on demand and self-services. Cloud computing customers use an automated interface and get the processing power, storage and network they need without the typical complex configuration required when building physical servers. Second, resources are accessible over a network from any location. Providers allocate resources to consumers from a large pool, allowing them to benefit from economics of scale. The resources exist in multiple locations all over the world. You just have to decide the available geographic location you wish to utilize. So resources are elastic. If you need more resources, you can get them rapidly, and when you need less, you can identify, you can scale back. So finally, you pay only for what you use or deserve, and you go. If you stop using resources, you simply stop paying. So this is the slide about an IT infrastructure is like a city infrastructure. So infrastructure is the basic underlying framework of facilities and systems such as transport, communication, power, water, fuel and other essential services. The people in the city are like users, and the cars and bikes and buildings in the city are like applications. So everything that goes into creating and supporting those applications, buildings for the users, citizens is the infrastructure. The purpose of this course is to explore as efficiently and clearly as possible the infrastructure services provided by Google Cloud. You will become familiar enough with the infrastructure services to know what the services do and have a good grounding on how to use them. So by the end of this course, you will be prepared to learn anything you need to know to use Google Cloud. Second agenda is cloud versus traditional architectures. So how do traditional architectures compare to the cloud? So this topic aims to answer this question. So, cloud computing is essentially the continuations of a model where you get to rent out computing infrastructure and have it managed by dedicated professionals. So Equinix and CenturyLinks are two of the largest data center providers in the US. So they are not exactly household names. So why are Amazon, Google, and Microsoft even in this business? In particular, why is Google doing cloud? The concept of cloud computing began with the conlocations. Instead of operating your own data center, you rented space in a collocations facility. This was the first way of outsourcing IT. With collocations, the transfer of ownership was minimal. So you still own the machines and you maintain them. Traditionally, collocations in this the not tough of as cloud computing, but it did begins the process of transferring IT infrastructure out of your organizations. Or organizations save money with the collocations by not having to build the data center and the associated services the collocations provide would simply rent all these out to your organizations. So next, cloud computing involve virtualized data center, virtual machine, and API. So virtualization providers simply generate the things, we can say the all the part of it, and the services automatically provisions and configuration the infrastructure used to run your applications. So Google Cloud uniquely positioned to propel organization into the next way of cloud computing. But what does cloud have to do with cloud? As we have already mentioned, the first wave of the trend towards cloud computing was collocations. Collocations gave users the financially efficiency of renting physical space instead of investing in data center real estate. So virtualized data centers shared similarities with the private data centers, and the collocations facility to dedicate past the component of virtualized data center match the physical building blocks of hosted computing servers, CPUs, disk, load balancers, and so on. But now they are virtual devices. So virtualization does provide multiple benefits. IT teams can move faster, and you can turn capital expenses into operating expenses. So with virtualization, you still maintain the infrastructure, and it is still a user control and user configured environment. So around 2009, cloud realized that its business could not move fast enough within the confines of the virtualization model. So Google switched to a container-based architecture, a fully automated, elastic third-wave cloud, and that consists of a combination of automated services and scalable data also. But the services automatically provisions and configure the infrastructure used to run applications. But sometimes today some services are being delivered into a fully automated serverless way. The trend will continue. A cloud service expands. So every company is a data company. So Google believes that in the future every company, regardless of size or industry, will differentiate itself from its competitors through technology. So largely the that technology will be in the form of software. So great software is centered on data. Therefore every company is or will become a data company. So Google Cloud provides a wide variety of services for managing and getting values from data at scale. This image shows Google's data center in Hamina, Finland. The facility is one of the most advanced and efficient data center in the Google fleet. Its cooling system, which uses seawater from a bay of Finland, reduces energy use and is the first of its kind anywhere in the cloud. So Google is one of the world's largest corporate purchasers of wind and solar energy. It has been 100% carbon neutral since 2007 and will shortly reach 100% renewable energy sources for its data center. The virtual world is built on physical infrastructure, and all those racks of humming servers use vast amount of energy. So together all existing data centers use roughly 2% of the world's electricity. So Google works to make data center run as efficiently as possible. So Google's data center were the first to achieve ISO 14001 certification as a standard that maps out a framework for improving resources efficiency and reducing waste. The third agenda is IASS, PASS and SASS. So in this next topic we will discuss the key difference between infrastructure as a service, platform as a service and software as a service together with the Google Cloud services that fall within these categories. With the infrastructure as a service, the service provides the underlying architecture for you to run servers. The resources to run are provided, but it's up to the users to manage the operating system and applications. Platform as a service takes it one step further. Now the entire environment will be managed for you, the users, and all that required of you is to manage your applications. The operating system layer will be managed as part of the service. For software as a service, the infrastructure platform and software is managed for you. All that required is that you bring your data to the system. A few commercial examples of SaaS including SAP and Salesforce. So virtualized data center brought your infrastructure as a service and platform as a service offering. So IaaS offering provide you with raw compute, storage and network organized in a way familiar to you from physical and virtualized data center. So PaaS offering on the other hand bind your code to libraries that provide access to the infrastructure your applications need, allowing you to focus on your application logic. So in the IaaS model, we can say infrastructure as a service, you pay for what you allocate. In a Paas model, you pay for what you use. So as cloud computing has evolved, the momentum has shifted towards managed infrastructure and managed services. So with managed services, rather than building complex component to work with your applications, you can leverage services that provides high performance and high availability. We can take an example. If your application requires some messaging services or machine learning or a database, rather than building these services yourself, you can just use a service Google Cloud already provides. So we will discuss a variety of managed services throughout this course. Next, let's focus on Google's specific offering in the cloud. So Google Cloud's products or services can be broadly categorized as compute, storage, big data and machine learning. So leveraging compute can include virtual machines via compute engine, running Docker containers in a managed platform using Google Kubernetes engine, deploying application in a managed platform like App Engine, running event-based serverless code using cloud functions, or running stateless containers as a managed services like Cloud Run. But as a variety of managed storage options are available as well for unstructured storage. These cloud storage for managed relational database. So there's Cloud SQL or Cloud Spanner and for NoSQL. So these are options like data store or we can say the cloud big table. So managed services dealing with the big data and machine learning are available as well. So Google's data center around the world are interconnected by the Google network, which by some publicly available estimates so carries as much as 40% of the world's internet traffic every day. So this is the largest network of its kind on earth and it continues to grow. So it is designed to provide the highest possible throughput and the lowest possible latencies for applications. The network interconnects with the public internet at more than 90 internet exchanges and more than 110 points of presence worldwide. So when an internet user sends traffic to a Google sources, so Google responds to the user's request from an edge network location that will provide the lowest delay or latencies. So Google's edge caching networks places content close to the end user to minimize latencies, and applications in the Google Cloud can take advantages of the edge network too. So Google Cloud divides the world into the three multi-regional areas: the Americas, Europe, and Asia Pacific. So the three multi-regional areas are divided into regions, so which are independent geographic areas on the same continent. Within a region, there are fax network connectivities, so generally round-trip network latencies of under 1 milliseconds. That is at the 95th that the percentile. So finally, regions are divided into zones, which are deployment areas for Google Cloud resources within a focused geographic areas. So you can think of a zone as a data center within a region, although strictly speaking, a zone is not necessarily a single data center. So compute engine, virtual machines, instances resides within a specific zone. If that zone become unavailable, so would your virtual machine and that workload running on it. But the deploying application across multiple zones enable fault tolerance and high availabilities. So behind the services provided by Google Cloud lie a huge range of Google Cloud resources, physical assist such as physical servers and hard disk drive, and virtual resources such as virtual machines and containers. So these resources are managed by Google within its global data centers. As mid 2019, Google Cloud has expanded across 20 regions, 61 zones, and more than 200 countries, and some other the expansions. So this expansion will continue. We can say when you take advantages of Google Cloud services and resources, you get to specify those resources. So geographical locations, we can say. In many cases, you can also specify whether you are doing so on a zonal level, a regional level, or a multiple regional levels. So zonal resources operate within a single zone, which means that if a zone become unavailable, the resources would not be able either. A simple example would be compute engine virtual machine instances and its persistent disk. So GKE has a component that is called a node, and these are zonal too. So regional sources operate across multiple zones, but within one region. So an application using these resources can be redundantly deployed to improve its availability. So finally, global resources can be managed across multiple regions. So these resources can further improve the availabilities of an application. So some examples of such resources including HTTPS Hypertext Transfer Protocol security, that is known as load balancer, and virtual providers. So we can say the Google Cloud resources used no matter where they reside, so must belong to a project. So what is a project? So a project is the base level organizing entity for creating and using resources and services and managing billings, APIs, and permissions. So zones and regions physically organize the Google Cloud resources you use, and projects logically organize them. So projects can be easily created, managed, deleted, or even recovered from accidental deletions. So each project is identified by a unique project ID and a project number. You can name your project and apply labels for filtering. So these labels are changeable, but the project ID and project number remain fixed. So project can belong to a folder, which is another grouping mechanism. You should use folders to reflect the hierarchy of your enterprise and apply policies at the right levels in your enterprise. You can nest folders inside folders. For example, you can have a folder for which department and within each department's folder. So you can have subfolders for each of the teams that makes it up, and each team's projects belong to its particular folder. So a single organization owns the folders beneath it, and organizations is the root node of a Google Cloud Resources hierarchy. So although you are not required to have an organization to use, so Google Cloud organizations are very useful. Organizationals let you set policies that apply throughout your enterprises, also having an organizational is something we can say organization is required to use folders. So the cloud Google Cloud Resources hierarchy help you manage resources across multiple departments and multiple teams within an organization. So you can define a hierarchy that creates trust boundaries and resources isolations. For example, should member of your human resources team be able to delete running database servers, and you should your engineers be able to delete the database containing employees salaries. So probably not in either case. So cloud identity and access management are also called a cloud IAM. So lets you fine tune across control to all the Google Cloud resources you use, and you just define the IAM policies and control users to access to resources. So next is so let's test what we have learned with the quiz. So the first question is which of the following is not a fundamental attributes of the cloud? The answer is C, security as a service, which does not exist. Next is select the Paas resources from the available options. So can you guess the answer? So App Engine is Google Platform as a Service. Next question is which of the following is an example of a journal resources? So just guess the answer. The answer will be Compute Engine. Compute Engine is an example of journal resources. So basically these are the quiz you can see. So this is the actual summary that concludes that. So what's the cloud anyways module? The simple answer to this question is that the cloud or cloud computing refers to software and services that run on the internet instead of locally on a computer. The advantages of the cloud is that you can access your information or any device with an internet connection. So another benefit of the cloud is that because the remote servers handles much of the computing and storage, so you don't necessarily need an expensive high-end machines to get your work done. So let us look at some of the key learning points from this module. So this is the actual summary. You can see at the start of this module we learn the cloud computing has five fundamental characteristics: on demand self services, broad network access, resources pooling, rapid elasticities, and major services. So we also drawn comparison between a typical city infrastructure and an IT infrastructure. We then discuss how cloud computing is a continuations of a long-term shift in how computing sources are managed. So looking back to how things were in the 1980s, so how things change through to today. So where we are heading next, the clouds as a Unix positional to propel organization into the next wave of cloud computing. So we also discuss the key difference between infrastructure as a service, which provides the underlying architectures to the run servers, platform as a service, which manage the environment for the users, so leaving them to manage their applications, and software as a service, which manage the infrastructure, platform, and software, requiring users to only bring their data to the system. So in the final topic you were introduced to a wide range of services that Google Cloud offers in the area of compute, storage, and networking big data with the machine learning systems. You were also introduced to the scope of the Google network as well as the concept of regions and zones. So lastly, we discussed the relationship between Google Cloud resources and projects. So this is my video. I hope you like this video. If you like this, please share and comment on this video. So thanks for watching.